This video will cover section 3.2 function notation. Students will be able to evaluate and graph functions from function notation. First, let's review function notation. So when we are naming a function, we say y is a function of x. So the way we write it is we use this f of x instead of y. So what we can see here is this y replaces or is replaced by the f of x. And these two are equivalent statements, meaning it doesn't matter which we use. However, when we want to indicate it's a function, we're going to use this f of x notation. The other thing you want to note is when you see this f with the parentheses and the x, it is pronounced as f of x. This is a function of x. Now what you will see with each of these is each of these are examples of functions. So what we can see here is I have this is a function of x, where I have all of these x's, and when I go to the right, I'm evaluating for the function with a heart, and instead of putting an x, I put a heart there. Similarly, for the next one, I have it's a function of x, where I have all of these x values, and then the next one I'm evaluating the function with a smiley face. So I put a smiley face wherever the x was. The next one I have a function of x again, where I have an x next to the 3, and for the right side I'm evaluating it for the value of a. So I put the a where the x was. And the last example is another function of x, where I have two x's, and the right side we're evaluating it for a value of 3. So the value of 3 is substituted wherever the x was. So what we can see is whenever you're evaluating a function, you're just putting something in wherever the x was. In this next example, we are evaluating from function notation. So if I want to find f of 3, if f of x equals 2x plus 6, what this means is that the variable x is being replaced with the value of 3. So my original function given to us here is f of x equals 2x plus 6. And what we should notice is that this value of x here is also over here. So if I wanted to now find the value of f of 3 as is given, what you're going to do is I'm going to rewrite the entire expression from above, but now I'm going to fill in a value of 3 in for this value of x right here. So it'll be 2 times 3 plus 6. Now if I simplify this, this will be f of 3, 2 times 3 is 6 plus 6, and then this simplifies to give us that f of 3 is equal to 12. So our final answer here would be 12. For the next one, it says find f of 2 if f of x equals 2x plus 3. So whatever my value of x is substituting here. So in this example, if I want to find f of 2 as is given, I'm going to rewrite the original problem, but I'm going to substitute this value of 2 in for my x. So it'll be 2 times 2 plus 3. So that gives me f of 2 equals 4 plus 3. And when I simplify, you'll get f of 2 is equal to 7. For the last one, we're again substituting this x based on what's given. So if I wanted to find f of 0.5 as given, I'm going to substitute this 0.5 in. So it's 2 times whatever the value of x is plus 3, and I'm substituting this 0.5 for x this time. So what it would become is it would be 2 times 0.5 plus 3. So you would have f of 0.5 equals 1 plus 3, which gives you the f of 0.5 equals 4. So the next example says, given that g of x is x squared minus 2, find each value. So if I want to evaluate each, what we're doing is whatever is in this value of x is substituting here. So now I'd be substituting 2 for the value of x. So my original expression is whatever the number is squared minus 2. So I would fill in a 2. And now I'm just simplifying from here. So if I do 2 squared, which we know is really equal to 2 times 2, gives us a value of 4. So g of 2 would be 4 minus 2. So you get that g of 2 is equal to 2. For the next one, I'm still using that original example, but now I'm substituting the value of 0. So if I rewrite my original from up above, as I can see here, I have it's the number squared minus 2, and I'm filling in this 0. So it becomes g of 0 equals, we know 0 squared is 0 times 0, which is 0. So it's 0 minus 2, which gives us that g of 0 equals negative 2. For the last one, I'm now substituting negative 4 for my value of x up above. So we know it's always the number squared minus 2, and now I'm substituting a negative 4. So if I have negative 4 squared, we know it's really negative 4 times negative 4, which gives you 16. So it becomes g of negative 4 equals 16 minus 2. So g of negative 4 is equal to 14. So we know that g of 2 is 2, g of 0 is negative 2, and g of negative 4 is 14. And we can see that even though the value with the function, so it's g of x instead of f of x, it's still going through the same process. And the next example, it says, given the following function in a domain, find the range. So what we're going to do is we're going to evaluate this function for every possible value of x. So our possible values of x are given to us right here. So this means that I would have to find f of negative 2, f of 0, and f of 3 as given to us here. So we know that the original function is negative 5x plus 11, and we're substituting this value of x in for x over here. So my original function for each of these is negative 5 times the number plus 11. And then I'm just evaluating it for whatever value is given. So for the first one, I'm filling in a negative 2. So I can fill in a negative 2 here. The next one, I'd be filling in a 0. So I can fill in a 0 here. And the last one, I'm filling in a 3. So I can fill in a 3 here. Now I'm just simplifying the expression. So the first one, it becomes f of negative 2 equals negative 5 times negative 2 is 10 plus 11. Then if I finish simplifying, I get f of negative 2 equals 21. For this one, I get f of 0 equals negative 5 times 0 is 0. So 0 plus 11. That gives me that f of 0 equals 11. And the last one, f of 3, negative 5 times 3 is negative 15 plus 11. So that becomes f of 3 equals negative 4. Now we know that the range is all the possible y values. So the range is the outputs, and the outputs are these different values. So you'd have 21, 11, and -4. So our range would be these values, and I'm going to rewrite them in order from smallest to biggest. So I have -4, 11, and 21 as my final answer. For the next example, it says, if f of x equals 2x plus 7, find when f of x is equal to 5. So what I need to do is instead of writing this f of x here, because we know this is also f of x, I'm going to substitute this 2x plus 7 in here. So this equation will become 2x plus 7, and it's still going to be equal to 5. Now I'm going to go through and solve like I would a regular equation. So I would subtract 7 from both sides. So you'd have 2x equals 2, and then to finish solving, 2x equals 2, I would divide both sides by 2 to get x is equal to 1. For the next one, where again it's f of x equals 11, so I'm going to take this 2x plus 7 and substitute it for f of x here. So I have 2x plus 7 is equal to 11. And now I would solve like a regular equation. So I can subtract 7 from both sides to get 2x equals 4, and then divide both sides by 2 to get x by itself. So you'd have x is equal to 2 as your final answer. So for the next example, it says, if g of x equals negative 3x minus 2, find g of x equals negative 2. So now, instead of having this g of x, I can substitute this negative 3x minus 2 and then solve for the value of negative 2. So what I would do is I'd rewrite this as negative 3x minus 2, and it's still equal to negative 2. Now to solve, to get x by itself, I'd first add 2 to both sides. So you'd have negative 3x equals 0. And then to finish solving, to get x by itself, you divide both sides by negative 3. So you'd have x is equal to 0. For the next one, it now says g of x equals negative 14. So you're going to substitute this g of x with this value of negative 3x minus 2. So you'll have negative 3x minus 2 is this time equal to negative 14. So to solve for x, we would add 2 to both sides. So you'd have negative 3x equals negative 12, and then divide both sides by negative 3 to get x is equal to 4. Now, function notation on a graph, you can graph an equation from function notation just like you would a regular linear equation. So the graph of f of x equals 2x plus 1 is the same as the graph of y equals 2x plus 1 because they both give us a slope of 2, or 2 over 1, and a y-intercept of 1, as we can see here. So I'd start at 1, go up 2 over 1, and I can graph. So this function, f of x, is the same as just being y equals. So in these examples, we're going to evaluate the function given the graph. Now we know that function notation is always f of a number is going to be equal to some number, where the number in the parentheses is the x and the number outside is the y. So if I'm looking at the first value, we want to determine what f of 2 equals. Now what we know is that this value of x is the 2, and the number outside the parentheses would be our y. And since ordered pairs are always written as x comma y, we know that this could be written as 2 comma, and we need to figure out the value. Now if I look at where I have 2 on the x-axis, if I go up, there's a point on the graph right here at 2, 1. So this means that there's a point at 2, 1. So f of 2 is equal to 1. For the next one, we're finding f of 0. Now in this case, we know that 0 is x. We don't know what this y is. So I could write it as 0, what number? And if I go to 0 on the x-axis and I go up, I see there's a point right here at 0, 1. So since I have a point at 0, 1, f of 0 is 1. For the last one, I have that we're finding f of negative 1. So x is negative 1 and y is this other value. So we know it's at negative 1, some number. If I go to negative 1 on the x-axis and I go up on my graph, I can see I have a point right here at negative 1, 4. So since it's negative 1, 4, my value of f of negative 1 is 4. So in conclusion, we can say that f of 2 has a value of 1, f of 0 has a value of 1, and f of negative 1 has a value of 4. For the next example, we're going through the same process, but now it's a g of x function. So if it's g of negative 4 equals what value? If I look, this means that x is negative 4 and y is what we don't know. So at negative 4, what is the y? And what I can see when I go to negative 4 on the x-axis, there's a point right here at negative 4, 0. So since it's negative 4, 0, g of negative 4 is 0. For the next one, it's asking for g of negative 1. So this means that x is negative 1, and what's the value of y? So if we want it's negative 1, what number? What I can see is when I go to negative 1 on the y-axis, and I go up, there's a point right here on the graph at negative 1, 6. So since it's negative 1, 6, the value of g of negative 1 is 6. For the last example, it's asking us for g of 4. So this means that x is 4, and we want to figure out what the y is. So it's at 4, what number? And what I can see is when I go over to 4 and I go up, there's a point on the graph right here at 4, 1. So since it's 4, 1, this means that g of 4 is 1. So my answers are g of negative 4 is 0, g of negative 1 is 6, and g of 4 is 1. Now we're going to go through the same process but work backwards. So what we know, again, is that with function notation, it's f of a number equals a number where this is the x and this is the y, which we know is like an ordered pair x, y. So what we know here is this f of x is what we don't know. However, we do know that y is 4. So we need to figure out what is that value that makes y 4. So if I find 4 on the y-axis and I go across, I can say I have a point right here at 5, 4. So since this could be 5, this means I could say that x is equal to 5. For the next one, we don't know what x is, but we know that y is negative 6. So we want to figure out for what number is y negative 6. So if I go to negative 6 on the graph and I go across, I can see I have a point right here at negative 2, negative 6. So since the x value that makes y negative 2 is negative 2, this means that x is equal to negative 2. For this last example, we don't know what x is, but we know that y should be 2. So for what number of x is y2. And if I look at the graph, I go to y is 2, there's a point right here at 0, 2. So this means that this x should really be 0. So you could say that x is equal to 0 to make the function equal to. For the next one, we don't know what x is, but we know that y should be equal to 1. So I could write the point as something, 1. Now when I go to 1 on the y-axis, I have a point here at -2, 1. So I can fill in a -2. However, I also have a point over here at 6, 1. So I could have -2, 1 or 6, 1. So since g could be either -2 or 6, this means that x could equal -2 or 6.